Good afternoon, everyone. Welcome to Android Development Training, Session 3. So, just to give a recap of what we saw in the previous session, we saw some of the controls like, I'll just share the screen, my mobile screen. So, just give a brief of what we saw in the previous session. So the first control which we saw in the unit 3 was a text view control. So basically this text view control is used for displaying the information to the user. In websites you might have seen that they display the information using the label tags or H1, H2, H3 other tags. So using those tags they display the information to the user. Likewise in Android there is a control called as text view which is used for displaying the information to the user. So this is how the text view control looks like. You just need to give the string for the control so that it displays the string. You can also give the foreground color. You can also give the background color. You can change the font family, font weight like bold, italics, other things. And also there is a concept called as marquee, which probably you are seeing over here. I'll just highlight that one. So the highlighting one where it shows you in the animation effect. So this is nothing but the text view control which is enabled with the marquee. So once it doesn't find any space, so what this control does is once it doesn't find any space to display the full information, it does a scrolling feature. It enables the scrolling feature. Same thing in the website you might have seen the marquee tag, right? In the website you might have seen the marquee tag which enables the text to keep scrolling from left to right or from right to left. The same feature is available even in this text view control. If the string is not able to display, I mean if the complete string is not able to display, then it enables this marquee effect. Only thing is you need to enable these properties which is related to the marquee. So this was the text view control. The next one was your button control. So this button control, I think you might be familiar, right? So if the user wants to perform some action, he needs to do some, he needs to click on something, right? So you can provide a button, you can provide the button for providing the user to do some actions. So when user clicks on this button, you can write some code that performs some particular actions. It's basically a triggering a event. And also the different types of registrations, the different types of registering the on-click event also we saw in the previous session. And also I've given you the source code of all those things. So probably you can just refer to that source code which I gave you in the last session. So the next control was your radio button. So the radio button allows the user to select any one of the options from the list. So you can provide n number of options. In the options, the user has to select at least one option. If you select the other option, the selected option will be deselected as you can see on the screen. So right now F sharp is selected. If I select C++, the F sharp will be deselected. So at that time you can select only one of the options. So that's the feature of the radio button. So the next one was your checkbox control. So again this is very much similar to your previous control except that in this checkbox control you will be able to select multiple options. Here you can select multiple options. The only difference between the radio button and checkbox is in radio button you can select only one option at a time and other options will be deselected. In the checkbox you can select any number of options and again any number of deselecting the options. So it is not mandatory. The next one was your toast. So this toast is not a control, but basically a library which is being provided by the Android for displaying the messages. I repeat once more, this toast is not a control. Please remember, toast is not a control, but it's just a library which is being provided by the Android framework to display the messages on the screen for the user. So this is the messages that can be displayed. Like if there is a validation error, so something like that, you can display these toast messages, which gets appeared, and again after a certain amount of time it gets disappeared. We have short toast, we have long toast, and also you can position the toast wherever you want, right? So this toast we saw in the unit 4, we saw the edit text control. So this edit text is used for taking input from the user. The opposite of this control was the text view control. So what does the text view control do? So using the text view control, you can only display the information to the user. But using this edit text, you can take the input from the user. So whatever the user enters inside the keypad, you can take it as an input and do some operations on it. So basically in the website they call it as a text box, or else you can specify input type equals to text. So in Android they call it as the edit text control. So there are different features available for this edit text control. So the first one which is been highlighted is a simple edit text control. So you can type whatever you want over there. The next one is so if you press the enter key, it goes for the next line. If you don't want it to go for the next line, you can say single line equals to true. There is one attribute called as single line. So you need to set the option single line equals to true. Probably I'll just show you that. So this was the project which I gave you in the last session. So probably you might have been referred to this one. So whatever controls which I'm explaining, everything is there in the source code. So this is the edit text control. So for the edit text control, if you don't want the cursor to go for the next line, you can say single line equals to true. So this will not allow the user to press enter and go for the next line, but rather the user has to enter everything in a single line. The next feature was your password. So whatever you enter, everything will be hidden. The next one was the date display. So when you put the cursor inside the date display, you can see that the the keypad changes. So what is the usual characters that will be entered inside the date? Usually it will be only numbers and hyphen, right? So you can enter only numbers and hyphen. So that is the characters, right? That is allowed inside the date. So you can't enter a dot, or ABCD, right? Because those are all not part of the date characters. Likewise, numbers. So you can enter the numbers. You have caps and autocorrect. Once you say caps, you can see that the first character will be caps. And autocorrect is, you can see the suggestions over here. So whatever I am able to select, so those are all nothing but the auto suggestion. The next one is your keyboard action send. So here you can see that the action is being changed over here, right? So search option is being set for this edit text. So I set the foreground color over here. I've set the background color. So these are all some of the features that you can find inside the edit text. Apart from that, there are a lot of other features which probably you need to explore it. So these are the controls that we saw in the previous session. So in today's session, we'll be seeing about the layout controls. So we'll start with the Android layouts. A layout defines the visual structure for a user interface, such as the UI for an activity or app widget. So in this unit, we will be learning some of the common layout types that are built into the Android platform. At the end of this unit, you will be able to understand or recognize some of the commonly used layouts such as linear layouts, relative layout, table, frame and grid layouts. Identify the attributes of the most commonly used layouts, identify the XML syntax to code the common layouts and also differentiate between the various layouts. A layout defines the visual structure for a user interface. So some of the commonly used layouts are these things: linear, relative, table, grid and frame layout. So you can declare a layout in two ways. Declare the UI elements in XML. Android provides a straightforward XML syntax that corresponds to the view classes and subclasses, such as those for widgets and layouts. So the meaning of the statement or the point is you can directly write the XML code for the linear layouts in the file, or else you can instantiate the layout elements at runtime. The application can create the view and view group objects and manipulate their properties programmatically. So the difference between these 2 points is, in the first point, you can create the you can create the layouts directly in the XML file. You can write the XML code and create the controls, or else the same controls you can create through Java language. Both give the same output. Only thing is that if you are sure that the layout looks something like that, you can declare directly that XML syntax in the file. If you are not sure about how your layout looks during the runtime, then you can do those things inside the Java file. Usually most of the times you predefine the layouts, right? You say name should appear towards the left side, text box, the edit text should appear towards the right side. So you fix the controls on the layouts, right? So in that case, you can always write the code directly in the XML files. There might be a situation where you want to create the controls dynamically. So in that kind of scenario, you can use the second point. So the first one is a linear layout. So basically the layouts or the layouts in Android is nothing but the building blocks for Android application. Like for constructing a building, how you use the cement, bricks, sand and other things. Likewise, to construct an application in Android, you need to use this linear layout. So I will consider that this can be called as the building blocks for any Android application. So these are the most important controls that you need to understand for constructing a screen or an Android application. Because inside using these controls you put all the remaining other controls like radio button, checkbox, linear text box, edit text, text view, all those things. So we'll see with the first one. Linear layout is a view group that aligns all children in a single direction, vertically or horizontally. All children of a linear layout are stacked one after the other. Vertical list will only have one child per row, no matter how wide they are. Horizontal list will only be one row high, the height of the tallest child plus padding. So it's very simple. Linear layout can contain two attributes. One linear layout contains an attribute and two properties for it. Orientation. The attribute name is orientation. So orientation can contain only two possible values. One is horizontal or vertical. If you see the linear layout is horizontal, then all the controls inside the linear layout will be horizontally aligned. If you say the linear layout is vertical, then all the controls will be vertically aligned. That is one below the other. It's basically vertical is nothing but the one below the other. Horizontal is nothing but one after the other. Everything in a single row. So horizontal is nothing but a row and vertical is nothing but the columns. Sorry, horizontal is nothing but the columns and vertical is nothing but the rows. So in vertical you can create a number of rows and in horizontal you can create a number of columns as long as you add space on the screen, or else it will go out of the screen. So that you should enable the scroll view feature so that the user will be able to scroll the controls. So some of the attributes which is available for this linear layout are these things. I think all are common things which I explained in the previous session. Only thing is that you have this orientation property. You can also set the divider. This is a drawable used to a vertical divider between the buttons. So if you want some color between the rows or columns, you can set this attribute. This is the most important one, orientation. You need to set the orientation to be horizontal or vertical. So this is the syntax for the linear layout. So you have the linear layout over here. Inside this is the syntax. You're opening the linear layout over here and you're closing the linear layout over here. In middle you have the first children and you have the second children. So you have two children inside this linear layout. Since I set the orientation as vertical, the first child and the second child will be placed vertically, one below the other. If I set the orientation to be as horizontal, then the first child and the second child will be placed horizontally, one after the other. So the next one is your relative layout. Okay, but I'll just show you one of the samples for this thing. I've created a sample for this unit and also the other units. So here you can see that I've declared a linear layout. I've declared two linear layouts present in the relative layout. I'll be explaining the relative layout later. After explaining this linear layout. So for time being, you can just understand about this linear layout. Here you can see that I've placed three controls. Right? I've placed three controls. So the orientation for this is vertical. You can place any kind of control in the sense you can place button, text view, edit text. You can also put one more linear layout in other linear layout. You can do nesting. You can put any kind of controls inside the linear layout. So whatever controls you put inside the linear layout and whatever orientation you have set, that will be displayed accordingly. So here you can see that I've set the orientation to be as vertical. So that's the reason you are able to see these controls displayed vertically over here. So you can see the first text view one, second text view 2 and the button control. So this was the first linear layout. And second linear layout, you can see this example over here. All the controls are being placed horizontally next to each other. So you can see the orientation is horizontal. So that's the reason you are able to see all the controls horizontally. So what I can do is I can just copy this control here. It gets displayed towards the right side. If you want to reorder the elements, you can reorder. So you do whatever you want inside the linear layout. It places the elements accordingly as per the orientation. So I'll just show you the output for this one. So the same thing which I explained you, this is the output for it. I'll be giving you the source code for this project at the end of the session, so that you can glance through the source code and understand the concept. The next one is your relative layout. Relative layout is the view group that displays the child views in relative positions. It lets child views specify their position relative to the parent view or to each other. Child elements can be specified in positions relative to the parent, such as aligned to the bottom, left or corner. So simple, even this control is simple. So the meaning of this control is you can place the elements wherever you want inside the relative layout. Unlike linear layout where you specify the orientation as horizontal or vertical, you don't need to specify any orientation inside the relative layout. You can specify their positions where the control needs to be displayed. Either the control wants to be displayed at the left top corner of the screen, or bottom right side corner of the screen, or left side corner of the screen, or towards the center of the screen, or towards the center horizontally of the screen. So like this, you can always set the positions where the control needs to be displayed. And also you can display the control next to the control or below the control, where you need to specify their variable names, which I will be explaining you in the code. So basically in this relative layout, you can position the elements wherever you want on the screen, like left top, right corner, right side corner, left side corner, top, right side. So all these positions. So the attributes are very much similar, except that here you can specify the layout gravity. So in this layout gravity, inside this layout gravity, you can specify their position, like start, end, bottom, left, top, right, corner. So all these positions can be set. And all the remaining attributes is, it's pretty much the common as the previous controls itself. So these attributes like layout width, layout height, ID, all these are common for the entire Android controls. And also you have these two other properties like layout below and layout above. You can say a control to be displayed above the parent or below the parent or next to the parent or other places using these attributes. So this is the syntax for the relative layout. Here you have the relative layout which is being declared, and under this relative layout you have one children and you have the second child. So here you are closing the relative layout. So inside this relative layout you have two children. So here you are saying the first control needs to be displayed. You are not setting anything over here. But if you observe the second one, you are saying that this button control should be displayed layout below ID text 1. So where is this control? It's there inside this So this control is there being declared over here, right? So you are saying that this button control should be displayed under this control. So that's the reason I told you need to specify this variable names over here. Since you have specified the variable name as text, and if you say layout below equals to text, this button control will be displayed below the text view control. So you can use the layout below or layout above. If you say layout above, then this control will be displayed above this text view control. Okay, before going for the next control, I'll just show you the output of this controller. So this is the best example. Here you can see that inside the relative layout, I've placed button controls at different corners of the screen so that you'll be able to understand the placements of it. So if you see the source code of it, you'll be pretty much, you'll be very easily able to understand how this control looks like or works like. So in this you can see that I placed the controls in different corners. I'll just show you the source code of it. There is no Java code written for this control. It's just that I have done some designing over here. Wherever there is a source code, wherever I've written the Java source code, I'll be showing you this one. So if you go for this relative layout activity, you can see that I've not written any code since I'm only demonstrating it. And there is nothing which is required for this thing. So here you can see that for the first control, I've specified layout align parent left equals to true. So that's the reason you're able to see this control towards the left side. And here you can see that align parent right equals to true. So that's the reason this control is being displayed towards the right side. As well as I'm specifying the align parent top equals to true. So on the screen, it will display in the right top corner of the screen. So if you see this one, so if you see this one, align parent right equals to true and align parent bottom equals to true. So right and bottom are set true, so it displays over here. Likewise, has different attributes for these controls. So if you want the control to be displayed in center, you can set layout center in parent equals to true. So that's the reason you're able to see this control in the center. If you want right side center, then you can say center vertical equals to true and align parent equals to true. So what happens if I remove this attribute? You can see that the control is displaying towards the left side. So by default, the controls are displayed towards the left side top corner of the screen. If you want to change their positions, you need to specify their attributes. So this control can be understood only if you keep experimenting by placing the controls. Just by seeing the source code, you can't understand. So keep experimenting so that you'll be able to understand how this control works. Try to place the controls in a different positions. The next control is the table layout control. Table layout is a view group that groups views into rows and columns. Table row element is used to build a row in the table. Each row has 0 or more cells. Each cell can hold one view object. Table layout containers do not display borderlines for their rows, columns and or cells. So it's basically the matrix concept, right? You can create the rows and columns. In HTML, you might have heard about the table tag, where you can create the rows and columns using the TD tag or TH tag, TR tag or TD tag. So basically, TR is used for creating the rows and TD is used for creating the columns. So that was in HTML. Same thing in Android, you have this table layout control. which you can create the table format, rows and columns. So here you can see in the output that I've created I've created three rows over here. And first row you can see there are three columns. Second row you can see there is only two columns. In third row you can see there is only one column. So these are some of the attributes for the table layout control. So there is two more attributes, shrink columns and stretch columns. So in HTML you might have heard about the row span and column span, right? Where you can club the rows and columns. Likewise, even here we have shrink columns and stretch columns to combine multiple rows or to combine multiple columns or rows. So this is the syntax for the table layout. So here you are opening the table layout control and in the end you are closing the table layout control. In middle you are declaring a table row and you are placing first child and second child. So in this row you can find two columns. So you put any number of controls inside this table row, that many number of controls will be treated as the columns inside a particular row. That's it. So you create a table row tag. Inside a table row, you put all the Android controls. So all those controls will be treated as the columns in it. I'll show you the output of this controller. So this is the table layout control. Here you can see that I've created three rows. First row contains two columns. All the rows contain two columns except the first row. Second cell is empty. It's almost like a table matrix form itself. 0, 0, 0, 1 over here, 1, 0, 1, 1, 2, 0 and 2, 1. So here you can see that I've created a table layout control and remember thing, the entire table layout is present inside the parent relative layout. So inside this relative layout you can see that there is some namespaces which is being defined. So these are the namespace that is being defined so that these controls will work. What happens if I remove this namespace? Here it gives the error because it's something like a programming language. Before you use some library, you import the namespaces or packages, right? So that you'll be able to use those libraries. Likewise, even this XML or Android XML, you need to put these things. Only then the controls will work. So you can see I've given the width and height as match parent, and also I've given 10 dp padding. So that's the reason you are able to see the space over here. So you are able to see the space. Since I've given 10 dp, what happens if I give 40 dp? See, it gets inside still more. Since I'm giving padding towards all corners of the screen. If you want the padding specifically towards the top, then you can say padding top or padding right top end. So I'm giving the padding only on the top. Likewise, you can set different attributes for it. Okay, let's come back for this table layout. So inside this table layout, I have set the layout width and layout height as fill parent. You can either set fill parent or match parent, both are same. Only thing is that fill parent is being duplicated, so you're not supposed to use it. So you can set this as match parent. So here you can see that I have created 3 rows over here, right? Here I have created table row 1, table row 2, table row 3. So if you see the table row 1, you can see there is only one button control. So that's the reason you're able to see this button control. Likewise in table row 2, you can see there are 2 buttons. Likewise in table row 3, you can see there are 1 button and 1 text view. It doesn't matter what kind of controls it is. So what happens if I copy paste this control over there itself? See it? It goes outside the screen. So this is how the control works like. The next control is here, grid layout. The grid layout is a layout that places its children in a rectangular grid. Note the grid layout requires minimum SDK value of 14, which is defined in the Android manifest file Gradle based on your Android Studio. So to use this grid layout control, you need to have the minimum SDK greater than or equals to 14. Only then you can use this control. It is something like this control is available from 14 and more onwards, not less than it. So this grid is nothing but a matrix format. It is similar to your table layout except that it is a matrix format where you need to specify the rows and columns. I mean the number of rows and columns. In a table layout, you didn't specify any rows and columns, right? Directly you created a table row and put the elements in it. But in the grid layout, you need to specify the number of rows and number of columns that you will be using it or defining it. So these are some of the attributes for the grid layout. The only 2 extra attributes which is new are this row count and column count. So here you need to specify the number of rows and number of columns. The integer number needs to be specified, like how many rows and how many columns you are needed. I mean how many rows and how many columns are needed for the app. I mean not for the app, it's basically for the design. So this is the syntax for the grid layout. Here you can see that the grid layout is being declared and the grid layout is being closed over here, right? And here is specifying the column count is equals to 1. So this is getting displayed in the 0th position and this button is getting displayed in 1st position. So basically here you are creating 2 columns. I'll show you the output for this grid layout. So this is the grid layout control. It is very much similar to your matrix file where you need to specify the number of rows and number of columns, and each and every cell you need to place your controls. I'll show you the source code for this controls. So here you can see that for this grid layout I specify the row and column as 3. So and you're specifying the layout row and layout column to be as 0 and 0. So that's the reason you're able to see this control in 0th and 0th position. What happens if I change this column number to 1? See, both the controls are getting overlapped, right? So here you need to specify the row and column number. See, for each and every control I specified the row and column number. It's basically a matrix format which starts from 0, comma 0. The next control is your frame layout control. The frame layout is a placeholder on screen that you can use to display a single view. In frame layout, all the child views are added and placed like a stack. The most recent added are shown on the top. By default, controls within the frame layout will be overlapping each other. You can add multiple children to the frame layout and control their position within the frame layout by using gravity to each child using the Android layout gravity attribute. In short, this control is used for overlapping each controls. You can overlap the controls on each other. This will be useful whenever you want to display the images, and on top of the images you want to display some information on it. So this is the syntax for the frame layout. Here you have the frame layout declared, and you are closing the frame layout over here. And here you can see you are creating the linear layout and you are placing the two controls over here. It's just that you are placing the linear layout and overlapping it on the frame layout. Probably I'll just show you one example so that you can get some more idea about that one. So this is the frame layout example. So here you can see that there is an image which is being displaying to the entire screen. It is being taken by the entire screen, and on top of the frame layout and top of the image you are displaying the text view and over here, and also one more text view over here. So this you can understand that you can overlap the controls on each other using the frame layout control. So here you can see that I have declared my parent as frame layout. Instead of frame layout, I have given the image view. I have given the image view layout height and layout width as fill parent, or else you can also use match parent, which takes the entire screen space. And on top of that, you are displaying the controls. So here you can see that I have not specified anything for this text view. So that's the reason by default it's getting displayed towards the left side. And for this second text view control, I have specified the layout gravity as bottom and gravity as center. So that's the reason you're able to see this. So that's the reason you're able to see this bottom text view in the bottom center of the screen. So that was about your layout controls. So we'll go with the next unit, Android UI widgets part 2. In this unit, you will be learning more UI widgets or controls that you can use inside your apps. So the end of the unit, you will be able to recognize the UI widgets such as switch, toggle button, image view, and progress bar controls, and also the XML code, and also how to reference it in Java, and also some of the attributes which is related to those controls. So these are some of the UI widgets that we'll be seeing in this unit. So we'll go with the first control, switch widget. Switch widget is a two-state toggle switch that allows the selection between the two options. So here you can see this toggle switch. I'll just highlight this one. So here you can see this toggle switch control, right? Toggle switch control, sorry. So in this you can either, there are only two states for this control, either on or off. So this control can be used in situations like you want to turn on the music on and off, vibrating on and off, Wi-Fi on and off. So wherever there is only two states, on and off, checked or unchecked, you can use this control. So these are some of the attributes which you can use it. What is the text information that needs to be displayed? Whether the text to be displayed is on or off text. Split track to whenever you want to use the image, you can use this. Switch text appearance, the style for the text, and what text needs to be displayed. Text off and text on. Text to use when the switch is off or on. Whenever the control is in on or off, you can specify some text. Something like when the switch is on, you can say music off. When the switch is off, you can say music is off. So you can toggle between those things. And also the last one is switch padding. Minimum space between the switch and the caption text must be a dimension value, which is a floating point number appended with a unit such as 14.5 SP. You can specify the floating point number between the text and the toggle. The space that needs to be given between the toggle and the text. So these are some of the functions available for the control. The same thing, the attributes which you saw in the previous slide, the same thing you can control it through Java language. So to design a switch, you can see this control in the palette in Android Studio. I'll just show you for one control so that you'll be able to understand for the remaining controls. So all the controls you'll be able to find it see all the controls you'll be able to find in this palette. So this is the palette. So this is the palette. So all the controls are available over there. See, all the Android controls are available. So the one which we are seeing now is the switch control. So here you can see the switch control. So either you can drag and drop on the screen, or else you can write the code. I would suggest you not to use the drag and drop feature, because you manually type the code so that you'll be able to remember the syntax of it, rather than using this drag and drop feature. or else you can write the code over here. So this is the syntax for the switch. If you want to get the reference of the control, this is the code. I think we have seen these examples in the first session or second session itself, like how to get the reference of the controls in Java. You need to specify the variable name over here, which is being defined in the XML layout, and since it is the type of the switch control, you need to typecast it using the switch class, and then store that object inside a variable which is being declared over there. So this statement basically gets the reference of the switch control from design to Java code. I'll just show you the output of the control so that you get more idea about that one. See, this is the switch control. Right now you can see that the music is on or off. So if I if I tap it on the control, you can see music is turned on, right? See, if I just tap on it, the state changes. There are only two states, either on or off. So this is the switch control. I'll show you the code for this. So this is the switch control over here. So here you can see that I'll specify the text over here, which you can see over here, music on or off, and also the text off and text on attributes. And I have one more text view controller which is used for displaying the state of it. Probably I'll just show you how it works. See, whenever I change the state of it, the text view was getting changed, right? The text view was getting changed because I've registered the listener for that one. If you go for my Java activity file, switch activity file, you can see that here I'm getting the reference of the control. This is the text view control, and also I'm getting the reference for the switch control, and inside that I've registered this listener set on check change listener. So what this event does is whenever you change the state of it, either from on and off or from off or on, whenever you change the state of it, this particular event will be fired. This particular listener will be called. Inside that you have this on check change function. Inside this you can check if it is being checked. If it is being checked, you can say I'm displaying the text view as music is turned off, else it is turned off. So whenever the state changes, this particular function is called. So inside this function you can write the code. And the reason why I'm displaying even outside is initially when the app opens, you need to display something, right? So this code will be executed. Initially itself, I'm checking whether the switch is checked or not. The next one is the toggle button. This is same as your previous control itself, except that it's a slightly different one. A toggle button widget allows the user to change a setting between two states. You can add a basic logic toggle button widget to your layout with a toggle button object. So this is the example for that one. Two examples are being demonstrated over here. So before explaining these attributes, I'll just show you the output of it so that you'll be able to understand more easily. So here you can see this toggle button, right? If I tap on this button, you can see the control changes. Again, if I tap, it changes, vibrate, off. So it has only two states, either on or off. Only thing is that at a time you'll be able to see only one state. Likewise, in a switch control, you are able to see both the states, on and off. But at a time it can be only on or off. But you can see both the states, right? But inside this toggle button, you can see the state only one. At a time, you can see only one state, either on or off. So these are some of the attributes for the toggle button control. Actually, we won't be using all these controls, except that we'll be most of the times we'll be using only this ID control, which is basically used for declaring the control name, and also the most important one, text on and off. So you can find this toggle button inside the palette. So this is the syntax for the toggle button. And this is the check change listener. So whenever the state changes and if you want to capture it, you need to register the listener. So in the first statement, you're getting the reference of the control in Java. Next, you are setting the on check change listener. So whenever the state changes of it, this particular function will be called, which is similar to your switch control, right? Whenever the state changes, we used to capture it, right? Same thing even over here. Whenever the state changes, if you want to capture that and do some action, you can do it over here. I'll quickly show you the code for it. So this is the toggle button control. Here you can see that I am specifying the text on, vibrate on, text off is vibrate off. So that's the reason you are able to see this vibrate on. Whenever it is on, it is vibrate on. Whenever you change its state, it will be vibrate off. So that on and off text you are specifying over here. So if you see the Java file, same thing. Here I am getting the reference of the control. So whenever here I am using the set on click listener. Whenever I click on the toggle button, this particular event is called, and here I am checking whether it is being checked or not checked. This is one of the way. The code which I showed you in the sample, I mean the PPT was a different way, and this one is different. But both gives you the same output result. Only thing is that here, since the parameter is V, you need to convert this V into toggle button. You need to convert the view into toggle button and then access that control. The next control is your image button widget. Image button widget displays a button with an image instead of text that can be pressed or clicked by the user. By default, an image button widget looks like a regular button with a standard button background that changes color during different button states. See, this control is almost the same as a button control, except that this control can take a image. It is same as your button control, except that this control can take a image on it. Remaining everything is similar to the button control. So these are some of the attributes. These are some of the events, methods available for the image button. No, actually we never use these methods, but it's just available. And there are also still a lot of other methods which probably you need to explore. So you can find the image button in the palette, and the XML code for that one is this. See, everything is same as your button control, except that you can specify the background image. So here I am specifying Android:src equals to at the drawable, inside the drawable folder there is an IC launcher image. So I am telling this control to display the IC launcher image inside as the background image for this control. So this is the XML code, this is the Java code for getting the reference of the control. I'll just show you the output for this control. Here I put a background image. If I click on this, you can see the toast message, because for the button image button control I registered the on-click listener. It is similar to your button control, except that you can give a background image for it. So this is the code. So here I have the image button. I've set the center horizontal and center vertical equals to true, so that's the reason you are able to display the control in the center, since this control is there inside the relative layout. And I'm specifying the ID variable name for it. I'm specifying the images. So this A1 is the image. You can see the A1 image inside this drawable folder. Right? Remember one thing. You can't refer the images which is there inside your system. Since this is a Windows desktop, if I have the images in some other drives, I can't refer those images inside this app. Whatever you're trying to refer, everything should be part of the project. Especially if it is images, those images should be put inside this drawable folder. You can just copy and you can just copy. You can just copy this image and paste it inside this folder, on this drawable folder. So now you can start using this one. So for that, I have specified the path over here. Next, I am registering the on-click over here itself. So whenever I click on this button, image BTN click is called. So if I go for my Java file, you can see that I have registered the listener over here directly. So image button click. So whenever you click on the image button, this particular function is called and code is executed. So that's the reason you're able to see the source message whenever you click on the image button control. The next one is your image view control. The image view widget displays an arbitrary image such as an icon. The image view class can load images from various sources such as resources or content providers. So basically using this control you can display the images. So the highlighted one is nothing but the image. This is the image view control. So these are some of the methods available. And we have the image view inside the palette. So this is the syntax for the image view control. Here you need to specify, using the src attribute, you need to specify the path of it. And image, as I said, the images should be present inside your drawable folder. And this is how you get the reference of the image view control. So this is the image view control. So here you can see that I have displayed 3 images. So there are 3 image view controls: first image view, second image view, and third image view. So all the 3 images are being displayed using the image view control. Not in single control, 3 separate controls. Each control can take only one image. So here you can see this thing, right? So inside my linear layout, I set the orientation as vertical. So that's the reason you're able to see all these 3 image views in a vertical fashion, right? So here you can see that I'm displaying 3 image views where 3 images are being displayed. Using the src attribute, I can define the images. And also for the image view, I can give a background color. See, I have specified the background over here. Scale type, there are different orientations for this image. You can also specify fit, there are these attributes. Either you can say fit center. See, if you say fit center, the display changes. It displays in center. Center inside. See, there are a lot of attributes. Fit end, or else you can say fit XY. It occupies the entire screen. So this is the image view control. The next one is your progress bar control. A progress bar widget is a visual indicator of progress in some operation. Progress bar widget could be circular or horizontal. For horizontal progress bar, the application can display the amount of progress as bar moves forward. So this is the horizontal progress bar. You can for example, you can display the amount of percentage, the percentage of the operation. If you are downloading something, you can display that inside using this control. Like 20% is completed, 50 is completed, 70% is completed, and so on. And the other one is your circular. This circular, actually the full thing is not being displayed, but this is the circular progress bar. When some background processing is being happening, then you can display this progress bar, which is circular one. So these are some of the attributes. So if you want a horizontal progress bar, then you can set this attribute. In this mode, the progress bar plays an infinite looping animation. It keeps circulating for infinity. Interdeterminate drawable. If you want to use some image, you can also specify the max, such as 100. If you are using a horizontal progress bar, then you can specify the max. Likewise, max height, max width, and the progress. If you directly specify progress equals to 50, then immediately the 50% is completed. For example, if you set the progress as 20, then here you can see, right? So by default 20 is being completed. It's just an example I'm giving you. So here you can see that at least 20% is completed if you set the progress to be as 20. So it's basically setting the default value for it. So these are some of the functions available. So you have different kinds of progress bars. Here you have different kinds of progress bar over here: large, normal, small, and horizontal. The first three are almost the same, except the size of the progress ring are different. And the last one is your progress bar, which is the horizontal one, which you can see over here. So this is the syntax for the progress bar. Here you have the progress bar control, and I've set the indeterminate equals to false so that it keeps circulating for infinity. And if you want an horizontal progress bar, then you need to set this style. Remember this one. If you use this syntax, then you get a circular progress ring. If you want horizontal, then you need to specify this style over here. Fine. You need to specify this style for the progress bar so that you get the horizontal progress bar. This is the code for accessing the progress bar control in Java. I'll just show you the progress bar code. Okay, before that I'll just show you the output for it. Here, this is the progress bar. These three are progress rings: large, medium, and small. This is the horizontal progress bar. I'll show you the code for it. So here you can see that I'm displaying text view over here just to give some information like downloading music. Next, I'm displaying a progress bar. As I said you, if you want horizontal progress bar, then you need to set this style, right? Since you set this style, you get this horizontal progress bar. And as you can see, by default, 70% is completed, right? The reason is here I set this progress to be as 70. Here, if I change this to 40, here you can in design you can see it is changed to 40 percentage. Likewise, you have the other progress bar controls. So here you can see the style is large, style is okay. If you don't specify anything, the style is medium. And if you want a small progress bar, then you need to specify progress bar style small. Except that all these three are same, except that the sizes are different. And since this you need to keep incrementing the progress, that needs to be written in the Java file. So inside my Java file, I have registered the event. So here you can see that I'm using the handler for creating a new thread and keep incrementing the progress bar percentage. So here I put the comment also. You can create your own threads and communicate back with their main application thread using a handler. This is done by calling the post method, but from your new thread. So you can create a new thread and interact with the controls. So for that you need to use this handler. So I've declared a handler over here. I'm declaring two variables, progress bar variable object and text view progress bar object. I'm getting the reference of these two controls. Next, I'm running a new thread, and I'm running using the implementing the runnable interface. Since this interface contains one function called as run, right? So I'm creating a new thread and implementing the runnable interface. So immediately this function will start to run, public void run. Since you're calling the start method on it. So once you call the start method on it, immediately this public void run function will be executed. So here you can see that inside a while loop, I am running it, right? So initially the progress bar value is, initially the progress status variable value is 0. So first time 0 will be less than 100, right? So condition is true. You're changing the progress bar status to 1. Next, inside the handler.post, and again I'm creating a new interface inside the run method. I'm changing the status of the progress bar. Progress bar dot set progress status. Whatever the incremented value is present inside it, I'm setting it for the progress bar. So dynamically you keep incrementing the value of the progress bar. And the same thing you are setting inside for the text view. And after assigning the value for the progress bar, I'm sleeping the thread for 2 seconds, 2 milliseconds, sorry. So sleep for 200 milliseconds just to display the progress slowly. If you don't use this 200 milliseconds, you won't find the difference. In a single shot, you can see that the 100% will be completed. So I'm just giving a bit of delay. So this was the progress bar concept. I'll be sharing you the source code at the end of the session so that you can download the source code and refer to the code which I've explained you now. So that try running this application on your device and see the source code, how it is. So that you get some more clear picture about that one. Okay, we'll take a break for 2 minutes, 2-3 minutes, and then we'll start with the next module. I'll just explain once more. So this is the most important unit that contains the most important concept that we'll be using in entire Android app development, because using these controls, whatever we see now is the most important one which we use in each and every Android application. For example, you might have seen the WhatsApp, right? In WhatsApp you display all the contacts vertically, and also you see the chats also which is being displayed vertically. So wherever you see to display the records, you might have some n number of records. So to display those records in some kind of design, you need to be using these controls which I'll be explaining you shortly. So these are basically the containers. As the word container itself suggests that you can put in other controls inside this container. It's a group of other controls, something like your layout controls itself, but works in a different way. In this unit, you'll be learning about some of the Android containers that you can use in your apps. At the end of this unit, you'll be able to recognize some of the most commonly used containers such as list view, scroll view, and horizontal scroll view. Identify the XML syntax to code the containers, and identify how containers are referenced in Java, and also some of the attributes for those containers. So let's see what are those containers are. So these are the containers: list view, scroll view, and horizontal scroll view. So some of the most frequently used are these things. An Android, so we'll see with the first one, list view container. An Android list view container is a view group that displays a list of scrollable items. You can see towards the right side the figure. You can see there are different kinds of string, different kinds of items which is being displayed, right? So that is nothing but the scrollable items. An Android list view is made up of a group of items. List items are individual rows in list view where the data is displayed. So here you can see that these are nothing but the individual rows, right? Any data in list view is displayed only through list item. So whatever you see over here is nothing but a list item. Even though it might be just a list, behind the scenes it is called as the list item. So each and every row is nothing but a list item. The list items are automatically inserted to the list using an adapter. So the most important concept, adapter. So you just remember, the list items are automatically inserted using an adapter. Android adapter is a bridge between the view, example list view, and the underlying data for the view. So your views are nothing but your list view controls, your buttons, all these are nothing but the children of the view. Like in Java, you have the object class, right? Under the parent, object is the parent class in Java. Under the object class, we have different kinds of child classes, right? And the parent will always be the object. Likewise, all the Android controls, the parent is view. So under view, there are different kinds of children like button, text view, list view, grid view, daytime controls, and other controls. So an Android adapter is a bridge between the view and the underlying data for the view. So in this figure, you can see that your view is nothing but the list view. Please be careful over here. So this adapter view is nothing but the list view, right? And this is nothing but the data source. It can be a list, it can be an array, it can be a cursor for the database, or it can be the data coming from the network. Whatever is it, it is the data source. So before giving this data source for the list view, you need to give this data source for the adapter. Adapter will give the data for the adapter view or the list view control. So adapter acts as a mediator between your data source and the list view control. Remember this one. Adapter acts as a mediator. I repeat once more. Adapter acts as a mediator between your data source and the list view control. So whatever data you are supposed to give for the control needs to go between the adapter. You need to give the data for the adapter, and adapter will handle and maintain and give it for the, it basically prepares and hand over the data for the control, your list view control or the view concept. An adapter manages the data and adapts the data to the individual rows of the view. Bind the adapter with the Android list view using the set adapter method. So once you give the data for the adapter, you can give the adapter for the control using this set adapter, which I'll be explaining you in the coding. For time you can just understand that once you give your data for the adapter needs to be given for the control, right? Your list view control. So for giving that one, you can say list view dot set adapter of your adapter object name. To interact with the view, adapters call the getView method. The getView method returns the view for each item within the adapter view, which is the list item. These things I'll be explaining in the coding so that you get a clear picture of that one. So these are some of the attributes for the list view container or the list view control. So if you want a divider between the items, you can specify the divider and also the divider height. Basically, the divider is nothing but the color to be given. So these are nothing but the methods available. Add header view, add footer view, set divider, other things. So these are the functions available for the list view control. So you have this list view control inside the palette. Inside the containers category, you have this list view control. So the syntax for the list view control is this one. Just you declare a list view and also give a variable name for it. So using this variable name, you will be giving the data for it through Java. So this is the syntax. So here you are getting the reference of the list view control. Fine. Here you are getting the reference of the list view control and storing it inside this object. Next, you are declaring a data source, which is nothing but an array or a list or a collection. So I'm just declaring a array over here which contains 4 elements. All the 4 elements are stored inside this list item object variable. Next, I have to use this array adapter for binding the data for the list view control, which we saw the adapter concept, right? So you need to give the data, which is nothing but the list items for the adapter. So you need to declare an array adapter. You need to declare an object for the array adapter of the type string, since you are specifying the string object, right? So you need to specify the type over here, string. Next, the adapter list object equals to new array adapter string you need to pass three parameters. One is your current activity reference, one is the style, and one is the array. That's it. So for this array adapter, you need to pass three parameters. One is your current activity reference. Second one is your list style, how the list needs to be displayed, what color, all those things. This is a built-in style. You don't need to do anything. This is the built-in style. And the third parameter is your array, which is nothing but which contains these four records. So after defining an object for the adapter, you need to give this adapter for the list view. You know, as I said in the PPT, you need to use the set adapter method, right? So you need to say list view dot set adapter of adapter list. So when you say list view dot set adapter of adapter list, you are giving this adapter for the list view control. So here you are giving this data source for the adapter. Next, you are giving this adapter for the list view, which we saw in the previous slide, right? You need to give the data source for the mediator, which is nothing but the adapter. You need to give the adapter for the list view control using this set adapter function. So now if you run this code, you can see all that items being displayed, like A, B, C, D is being displayed vertically. So here is a click event handler. So there might be a situation where when you click on any one of the items, you need to capture it and do some action. For example, in your WhatsApp, we display all the chats, right? We display all the contacts or the chats. So when you click on any one of the particular contact, you are navigated to a different page where the chat is being shown between you and them, right? So there is a navigation between the main page to the other page where all the chats are being displayed, which is pertaining to you and them. Likewise, even over here, when you click on any one of the items and if you want to perform some action, then you need to use this on-click event. So you need to declare an event handler. You need to create an adapter view dot on item click listener. Assign it to the list view by calling the set on item click listener and this syntax. View dot on item click listener is the interface definition for a callback to be invoked when a list item is clicked. Set on item click listener registers the callback to be invoked when a list item is being clicked. So this is a function of the list view. Set on item click listener is nothing but the function of the list view. Inside this here you need to pass a parameter of the type view dot on item click listener. The code to be executed when the list item is clicked must be written inside the overridden on item click function. So here you can see that example is list view dot set on item click listener. For this set on item click listener, you are registering an interface called as adapter view dot on item click listener. Fine. Once you implement this interface, there is an overridden function called as on item click. So whenever the item is being clicked, this particular function is called. Understood? So I repeat once more. You need to register this listener over here event adapter view on item click listener interface. So once you implement this interface, you have this overridden function on item click. So you can write the logic over here. So whenever an item is clicked and if you want to perform some action, you need to write the code over here. So I'll just show you the output of the controller. So we'll see with the first one, the list view control. Here, automatically the horizontal vertical scroll bar also is enabled. If the number of items goes beyond the screen, then automatically the vertical scrolling is enabled. So you can scroll through the list of items. Here, these are all nothing but the items, list items, which is being displayed using the list view control. See, whenever I click on any one of the items, it's displaying the toast message, right? So I'll just show you the source code of it. So this is the most important control which you need to understand. So here you can see that here I am using the list view control. I'm using the list view control. I'm selecting. Whenever you select an item, if you want a color, background color, you can use the list selector and the color code. And also, if you want a divider color, you can use this divider color code. And also, if you want the divider height, you can specify the divider height over here. Fine. And now, see this. Whatever you see over here is just a output which is being demonstrated like how it looks, but actually when you run this you won't be able to see this output. Rather you need to give the data through the Java code. So if I go for the Java code of this activity, so this is my list view activity Java file. So here you can see that I have declared a list, right? I have declared a list which contains this string items. Fine. Next, I am getting the reference of the list view control. List view item is nothing but my control name which is present inside my XML file. So here you can see this list view item, right? So this is my variable name. I am giving this variable name. I am trying to get the reference of this control and storing it inside this list view variable. Next, as I discussed about this one, you need to declare an adapter object and pass 3 parameters. One is the current activity reference. You can get the current activity reference by calling the get application context. Get application context is a built-in function which gives you your current application reference. Next, you need to specify the style. This is a built-in style. And next, the list. List is nothing but the collection of data. So once you declare an adapter, you need to give the adapter for the list view control by calling the set adapter function. So if you call the set adapter function, and you need to pass the adapter object. So once you set this adapter for the list view, automatically the items will be displayed on the screen, right? Next, when you click on any one of the item and if you want to perform some action, this is the code. So here I've demonstrated 3 different ways. So first one is, okay, let me explain those things later. So first I'll explain the on item click listener. So whenever some action needs to be performed when you click on any one of the items, you need to register the set on item click listener. So listview.set on item click listener, which is the function of the list view. Inside this, you need to register the interface new adapter view dot on item click listener. So inside this interface, you have this on item click overridden function. So here you can see that adapter view dot on item click listener. So the same thing is used even over here. Adapter view dot on item click listener interface. So inside this interface, you have this on item click function. Method which is being overridden. So inside this on item click, whenever you click on any one of the items, this particular on item click is called. So inside that, I am displaying the message source.makeText get application context, and you need to get the position of the item, right, whichever you have clicked. So to get the position, you can use this syntax. List view is nothing but my control name. Get item at position is the function of the list view position. So whichever item you have clicked, that position will be passed for this function on item click position. So you can pass this position number for this get item at position, and it will give you the value of it. So you are getting the item and displaying it and concatenating with the click. Here, if I click on any one of the items, you can see Symbian clicked, right? So that Symbian or the Windows or Android is being retrieved from this code, and you're concatenating the clicked string first one. So to get the current item which is being clicked, this is one of the way. Second way is you can use this syntax. Everything is same except that here you can say parent.getItem at position. That's it. Parent is nothing but a parameter which is passed for this on item click. So when you say parent.getItem at position, it will give you the same output itself. Only thing is that 3 different ways are demonstrated for you to get the current item which is being clicked. I repeat once more, 3 different ways are demonstrated here to show how to get the current item which is being clicked. You use any 3 concepts, any of the 3 concepts, you get the same output. So this is the list view control, and I just show you how to register the listener. See, now if you want to register the listener, what you can do is listview dot set on item click listener. I already explained you these things earlier. I'll just explain once more. Listview dot set on item click listener. Select the function, press enter. See, now it is showing you what is the parameter that needs to be passed. So here you can say new on item click listener. So once you start typing on item, it will display you this suggestion. So select this option and press enter. Here automatically the code is generated. I request you, please don't type this code. You try to use this feature, it will generate the code automatically, so that if we type, we might make some mistakes, right? So it's better that let the Android student generate the code and give for us, so that our work will be easier and also we won't be making any mistakes. I'll just show you once more. Listview dot set on item click listener. Here you need to say new on item click listener, press enter. It will generate the code automatically. That's it. Whenever you're registering the listeners or item clicks, this is the concept that you need to follow. It's not only for the list view, it can be for any controls in Android. You try to use this built-in feature which will generate the code automatically. So this was the list view control. We'll go with the next control. The next control is your scroll view container. Scroll view is a special kind of container designed to hold view larger than its actual size. If the view size goes beyond the scroll view size, it automatically adds scroll bars and can be scrolled vertically. Scroll view can hold only one direct child. Remember this point. Scroll view control can take only one child. It cannot have multiple children. You should never use a scroll view with a list view because they both take care of their own vertical scrolling. You know, as you saw in the previous output, if the number of items goes beyond the screen in the list view, it automatically enables the vertical scroll view, right? So you shouldn't use the scroll view inside the list view control. Scroll view supports vertical scrolling. For horizontal scrolling, use the horizontal scroll view. So basically using this control, if you have some, okay, for example, if you have a big data entry form where the user needs to enter name, age, date of birth, gender, occupation, school, college, education, it's a very big form. So you can't display all those controls in the screen, right? It might be insufficient for display all the controls. So what you can do is all the controls you can place it inside the scroll view control. So automatically you can scroll the controls. From there, just show you the output so you get more idea about that one. So if you have multiple controls, many controls, sorry, you can use the scroll view controls and put all those controls inside the scroll view. So that even if the control goes outside the screen, using the scroll view, you can scroll the screen. So these are some of the attributes. I think the first three is common. Second one, scroll bar. There are different properties, values for the scroll bar. If you want the scroll bar to be displayed, you can display, or else you can say scroll bar is equals to none. So the small, you might have seen in the browsers, right? Right side you can see the scroll bar. Likewise, even in Android, if you want to see the scroll bar, you can just leave as it is. If you don't want to use the scroll bar, if you don't want to see the scroll bar line, you can say scroll bar is equals to none, which doesn't display the scroll bar line. Next is the visibility. If you permanently want to make it visible or invisible or gone, release it from the memory. Basically hiding the control or showing the control using this visibility attribute. This visibility attribute is available for all the controls in Android. It's not specific for the scroll view. It's available for all the Android controls. So you can set the visibility for the controls and make it visible or invisible, either through XML code or through Java code. So these are some of the functions available for the scroll view. So you can find the scroll view and horizontal scroll view in the palette. So this is the scroll view control. So as I said, your scroll view can contain only one child. So inside a scroll view, you can put a linear layout or a relative layout, and inside a relative or linear layout, you can place other controls. And this is the code for the horizontal scroll view. The difference between scroll view and horizontal scroll view is scroll view will display the children in vertical fashion. Horizontal scroll view will display the children in horizontal fashion. That's it. Scroll view in vertical, horizontal scroll view in horizontal. I'll just show you the output for those two controls. See, this is a text view control. Here, inside the scroll view, I have put some 30 text view controls. See, if you can't display all these text views right in a single shot, so you can put all these text views inside a scroll view. So once it goes outside the screen, you can scroll and see the controls. It's not that you need to put only text view, you can put a mixture of all the controls, however you want. So this was scroll view, and we have one more horizontal scroll view. So inside this horizontal scroll view, you can scroll horizontally. That's the difference. The previous one was vertical scroll, and this one is horizontal scroll. I'll just explain you the source code for it. Okay, where is scroll view? Okay, you have this scroll view activity. So here I have just represented in a different way. So here you have the scroll view control. instead of scroll view control, I have a linear layout, right? But if you see the output, you are able to see 30 text views, right? How is it possible? Inside this linear layout and orientation is vertical, right? You are not able to see any text view controls, but in the output you are able to see 30 text views. How is it possible? The reason, the answer for that one is I am adding the text view controls dynamically. This is just a different way which I am demonstrating. I am creating the text view controls dynamically through Java and giving it for the list linear layout control. Or else you can directly give the text views over here itself. Yes, I can just give the text view directly over here itself. Like this, right? So this is one way, but this is a common way which everyone does. Just a different one I'll just show you, like how to create the controls dynamically and give it for the UI. So if I go for the Java activity file, here you can see that I'm declaring a linear layout object. I'm getting the reference of the linear layout. Inside this XML file, we declare a linear layout control, right? So I'm getting the reference of this linear layout. Next, I'm declaring an array of text views. I'm declaring an array of 30 text views. Fine. Next, inside my for loop, I'm declaring an object for the text view for each and every position. Next, I'm setting the position. I'm setting the position and setting the text. I'm setting the text dynamically. I'm setting the text size dynamically, and also I'm setting the text color dynamically. And finally, I'm adding this text view for the linear layout, like linear layout dot add view. It is adding the controls dynamically for the list view. So that's the reason you are able to see 30 text views. If you want more text views, you can increase the number over here. That's it. So this was the scroll view control. The next one which we saw was the horizontal scroll view, right? So again, this is very much simple. I have a relative layer to the parent. Inside that, I have declared the horizontal scroll view. See, instead of using this relative layer, you could have made this horizontal scroll view itself as a parent. It completely depends upon your design, how you want, right? Anyways, I have declared the horizontal scroll view. As I said you, the scroll view and horizontal scroll view should contain only one child. So there is only one child, that is nothing but the linear layout. For the linear layout, I give the orientation as horizontal, and inside this linear layout, I put the 10 button controls. Here, I put the 10 button controls. So that's the reason you are able to see this horizontal. That's the reason you are able to see this horizontally. And I have not written any Java code for this one. See, there is no Java code because everything I have done through XML file itself. So if you have remaining things like list view, all these things we'll be seeing in the next session. So till now, whatever I explained, please practice it. The list view, scroll view, and horizontal scroll view, and all the other controls which I explained in the previous unit. So once you're comfortable with this one, it will be very much easy. I mean, it will be very much comfortable using the other controls. In the next session, we'll be seeing about this unit 8, part 2, which is the most important one, list view custom. Here, you can customize the list view. The first one which we saw was the normal list view, right? So in this example, you can customize the list view control. So till here you can practice it. Okay, just give me 2 minutes so that I'll give you the link to download this project, whatever I've shown you now, and also the previous project. So you can download the source code and import it inside into your Android Studio and run and you can run and see. Just give me 2 minutes so that I'll share you the link to download that one. So this is the link. So you can download the source code, whatever I've shown you now from this link. Whatever samples which I was explaining now, you can download those projects from this link. And also whatever I explained in the first session, second session, and this session is present inside the download link. And also like first session, I showed you how to install the Android Studio, JDK. So all those things are present inside that. So you can go and download from this link. I've just shared in the chat window. Same link which I'm showing you where I've just shared. So whoever can just copy this link and download. So if you have any questions, you can ask now. Okay, with the remaining things we'll see in the next session. Thank you for attending the session. Have a great day.